Now let's learn how to create boundary, boss base and cut. Now boundary tools produce very high quality, accurate feature useful for creating complex shape for market focused consumer product, medical, aerospace and mold. Now it creates a solid by controlling the shape between two directions. Let's say this is one profile and this is second profile. So this is direction 1 and these intermediate curves are called direction 2. So it is like a 2 times a loft. So in this direction and this direction. So you can control the shape horizontally and vertically. So direction 1 is basically profile, and while direction 2 can be profile, curves and edges to control external surfaces. Now it gives much more cleaner and smoother geometry than loft in many cases. So sometimes user have a confusion what to use, either loft or boundary. Remember, as explained here, if you are in business of creating the consumer product where the outer surface are very important and critical, then try first loft. If you are able to achieve it, the result you desire, then it's okay. If not, then try the boundary boss base. Now in this exercise, I will try to create how to add the boundary base by selecting the two profile in direction 1 and this guide curve in direction 2. Now open the exercise 8.19. This time start the boundary boss. Here in direction 1 I will choose this circle and this circle. Now moment I choose, I have a floating window control where I have option like direction vector and normal to profile. Now in direction 2 I will choose these curves. So you can say it control the outer face surface in this direction as well as in this direction using these sketches. Here technically we refer is direction 1 and direction 2. Now because these are the curves, it does offer, as earlier explained in loft feature, like influence of next to curve, sharp, next edge. Similarly in direction 2. So because of this influence in two direction, it gives more smoother surface compared to the loft features. So let's go ahead and click OK. Now let's further explore boundary feature. This time we have only one sketch for direction 1 and 3 sketch for direction 2. So open 8.2 exercise file. Now let's start. Direction 1 is this, and for direction 2 all these curves. Now see the outcome. Because I have chosen 3 curves in direction 2, it helps these to create very controlled surface. Now here if I wish, I can change the options, right? Now it's depend on your requirement. So here I will choose only global and go ahead and click OK. So this way you can create a very smooth surface between two profile using boundary feature. Now in exercises 21, we'll try to use trim options. Now let's say I have two profile in direction 1 and in direction 2 I have only 3 curves like this. We assume that sometimes that these two profiles are connected to the end by the curves, but here we have only 1, 2 and 3. So this extension part is remain there. Now in that case we want to trim off the generation of surface by these curve directions. So in this exercise we'll try to explain the concept of trim by direction 1. Now open the exercise 8.21. Here I have unticked this option, trim by directions. So because of that, the direction 1 is extended for the entire length of direction 2. Now let's go ahead and edit the feature. Now look at very carefully. I have a sketch 1 and sketch 2. So this is 1 and this is 2. And it is controlled in direction 2 by this curve. Now curve is extending beyond these two profile. What I want is I want to terminate the surface generation exactly at this location. So here I need to choose trim by direction 1 and see the outcome. So here, because of this direction 1 on which the profiles are located, only between them the feature is created, not for the entire length of direction 2. Just go ahead and click OK. So sometimes you want result like this. So using that trim options you can do that. Now let's explore the use of standard holes. Sometimes in SolidWorks this is referred as holes wizard. Now hole wizard is feature that creates standard holes. Now try to understand what does it means. It has fixed size which are used in industries. So using industry norms such as ISO, ANSI, DIN, JAS and GB etc. So it creates exactly holes as per the engineering standards, including drill sizes, thread sizes, counterbore and counter slot. So here we have 9 type of standard holes. Now because it is standard, you have to choose the standards and relative standard sizes. Now what is the benefit of doing this? It gives precision, consistency and save a lot of time in design. Now what are additional benefit of it? All hole sizes match standards. That's a very important things. So moment you change, all the standard hole size change. Now automatically it create the cosmetic thread. Automatically include the call out in drawing. This is very important. So faster than creating holes manually, obviously, we'll see in practically. Ensure the manufacturing clarity. So because of it is call out available in drawing, it will clearly tell you what is this type of hole is and what is its size. Works with the smart fastener. Now using exercises 0.23, we'll try to place these standard holes. So look at over here, it is counterbore, countersink, through holes, a tap hole and the slot. Now what is the benefit? So moment I create a drawing of it, the call out with its standard size is available. So this is the purpose of using the standard holes in SolidWorks. So you do not have to add such informations manually inside the SolidWorks drawing. It is inbuilt moment you use the standard holes. Now open the exercise 8.23 and let's try to create standard holes as given in slides. Now let's try. So from this hole wizard, start the creation of standard holes. We have two things, type and positions. So first we need to select the type. Now I will choose the first option called counterbore. So select it. Here inside I will choose ANSI metric and from that I will choose hex bolt. So I will choose hex bolt ANSI 8.23. Now from the size I will choose M8. Now here we need to understand. So fit is normal, loose, you can select it or show custom sizing. Moment you do that, you can control what is this inside diameter, outside diameter, the depth, etc. Now because we are going to use standard holes, let's do not modify these sizes unless we require. Once we do this, make sure the end condition is through hole, because we want to create a hole from top to bottom. Now select the positions and 3D sketch. Now let's place over here. 3D sketch allowed to create holes on this surface and this surface. If you choose 2D sketch, you can only go for in one direction. So let's click. Now right click. So I have placed a counterbore of selected size. Now moment you select that feature, you can see the sizes. If you required some changes, just go ahead and edit the feature and activate the show custom sizes, and you can modify this if you require. Now let's try one more options, that is countersink. So start again. This time we'll choose this option called countersink. Now let's say size is unsymmetric, flat head screw, and this time I will choose M6 size. Let's go over and try select this 3D sketch and try to place over here and right click. Now let's try few more. This time I'm going to create a hole, that is through hole. So select this. Drill size this time is 8 mm. Let's say it's a 8. Then go over here and put it on this side. If you wish, you can also place hole over here, and that's a benefit of using 3D sketch. So same size of hole will be placed on two surface. Now let's try and try to put tapped hole. So choose these options. This time I will choose straight tap hole, or simply let's try tapped hole. Now size will be as given in the exercise, it is 10. And because it is thread, the M10 is your nominal diameter and pitch is 1. Now let's go over here and select the 3D sketch to place this thread and right click. Now let's try one more. This time we are going to create counterbore slot and choose appropriate options. Here I will go for X bolt, and dimension scheme will be like this. So let's try to add the dimensions. Now let's select the surface. Now let's try to change the dimensions from 20 to 25 and click OK. So this way you can place standard holes in your part file. Now open the provided solution file. Now we'll try to change the size of this hole, and we'll try to see is it get changed in dependent drawing or not. So let's go back over here, and instead of this especially the first counterbore, let's try to change the size from at 8, let's make it 5 and click OK. Now let's go to the standard hole. Now see, I change from 8 to 6, it get updated. Now let's try this slot. Again, go to standard holes, select this, edit this part. Instead of M10, let's reduce the value to M8 and click OK. Let's go to the standard hole size. So it does get update the value.